Okay, we are now moving into chapter 17. We've got 3 chapters left for the course, and we're kind of headed on target to finish right before spring break. Well, chapter 17 is just an expansion of looking at equilibrium and other applications where they kind of show up. So the first concept we're going to look at is this idea of the common ion effect. So let's say you have a solution here of, of acetic acid. So if I have a solution of acetic acid, I have acetic acid on the left, and then I have hydronium ions and the acetate ion. And remember that acetic acid is a weak acid, so therefore it's not all going to be in solution. So if we add acetate ion to the solution, according to Le Chatelier, equilibrium is going to shift to the left. We're going to get more acetic acid, and the hydronium ion will be consumed. So, the extent of ionization of a weak electrolyte is decreased by adding to the solution a strong electrolyte that has an ion in common with the weak electrolyte. So that would be the idea of adding more acetate ion to it. It's going to move it in that direction, which I feel like we've discussed at points when we've been talking about equilibrium in chapter 16 and chapter maybe it was 4. Anyway, moving on. Okay, so let's say we want to calculate the fluoride ion concentration and pH of a solution that is 0.20 molar HF and 0.10 molar in HCl. Okay, so basically we've got a strong acid, okay, the hydrochloric acid, 0.1 molar, and we've got a 0.2 molar solution of a weak acid, which is the HF. Now the Ka value for the HF is 6.8 times 10 to the negative fourth. Now we can rewrite Ka equals the concentration of H3O plus times the concentration of F minus, which is the conjugate base of the HF, over the concentration of HF. Okay, so that's just writing the expression, right, for the weak acid, and make that equal to the Ka. Now, because HCl is a strong acid, we have 0.1 molar concentration of H3O plus, and then we also have this 0.2 molar of the HF. So we've got 2 different initial conditions. So now we need to, rather than like the H3O plus just being 0 and using Ka to solve, we have to kind of keep in mind that, oh, we already have hydronium ions, so we're probably not going to see as much fluoride ions as we would have. So still using kind of that X value, okay, because we're going to have a loss and a gain in this situation, and so we're going to solve for these values. Now here's the deal. So remember how when we used X, so since HF is a weak acid, the X, or how much dissociates and goes into the products side, is going to be small, or yeah, very small compared to what the initial concentration is. So we drop the X when we are at equilibrium because we're assuming it's pretty small. But remember, we're trying to solve for the fluoride ion, which is X. But for the hydronium and the HF concentrations, we can just assume that X is very small, and so the initial concentrations, we could use those as the equilibrium concentrations. So then we could plug it into the equilibrium expression that we had written. Okay, so 0.1 over 0.2 times X, and solve for X, and we get a value for X being 1.4 times 10 to the negative third. Okay, pretty small, right? Not a lot of fluoride ions, but this would be another way to approach it, because it's actually a fairly common occurrence where you might be combining multiple ions into the same solution, and so thinking through, well, how is that going to affect the amount of ions dissolved? So therefore, the concentration of F minus is equal to X, which is equal to 1.4 times 10 to the negative third. Now, if we were to go and just double check and make sure our X, we could drop it, well, or to find the pH. So the pH is H3O plus is equal to 0.10 plus X. Well, X is 1.4 times 10 to the negative third, and that's pretty small. So considering that we only have two significant digits, that kind of leaves us with 0.10 molar for our concentration, and therefore taking the negative log of that gives us a pH of 1. All right, and that's where we're going to leave it for today. And then on Monday, we're going to talk about buffers. And then on Tuesday, we're going to have a buffer lab. So, all right, I will talk to you tomorrow.